In this example video, we have a sound generator that's emitting a sound at 300 watts. We first want to know what the intensity of the sound is at 10 meters away. We want to know what the intensity level of that sound is. And then we want to know at what distance from the source the intensity level is 100 decibels. In order to calculate the intensity, remember intensity is in watts per meter squared, we're going to use the fact that intensity equals power divided by 4 pi r squared. So I plugged in the power provided in the problem and the distance provided in the problem, and I end up with an intensity of 0.239 watts per meter squared. Now do be careful when you are using your calculator to put the entire denominator in parentheses here so you don't divide by pi and then multiply by everything else. In order to calculate intensity level, which is in decibels, we need to use the relationship that intensity level equals 10 decibels times the log of intensity over intensity naught, which is the threshold of hearing. So I plugged in the intensity that I got in part A. And remember, this is base 10 log, so you need to locate base 10 log on your calculator. And I get an intensity level of 114 decibels. Now, if I want to know what the intensity level at a different distance is, I need to use intensity level 2 minus intensity level 1 equals 10 decibels times the log of distance 1 squared over distance 2 squared. So let me go through the math in a little bit more detail of that, since it may have been a while since you've used base 10 log. So the first thing I'm going to do is take the 100 decibels minus the 114 decibels. That is going to give me a negative 14 decibels. And then I'm going to divide by the 10 decibels on both sides, giving me a negative 1.4. The decibels now cancel out. And then I'm going to do 10 raised to both sides. The 10 and the log cancel each other out, so we're left with 10 raised to the minus 1.4 equals 10 meters quantity squared divided by distance 2 squared. And from there it is traditional algebra, which you can rearrange to solve and get 50.1 meters.